Assalamualaikum. My name is Norliza binti Remus. Today I will present our project report, which is my part is concept and frameworks. First, I will present our case study. The case study for this report is Sekolah Kebangsaan Brickfields 1, Kuala Lumpur. This school is used the industrial building system IBS, which is precast concrete system. This project starting from 6 February 2003 and complete on 17 September. It takes around 8 months completion for this project. Okay. Sekolah Kebangsaan Brickfields 1 using concept of IBS, which is built with 4-story buildings, and for the component of this school is around 75% component in this building is prefabricated. Okay, for the purpose of IBS, use several component which is precast concrete system to be installed to a 3-story apartment building. This is also the precast system established quickly, save the time of construction and lower cost on the building. Okay, for framework of this IBS system project include case in situ pad footing, second case in situ ground floor slab, precast concrete hollow core slab, precast concrete staircase, prefabricated steel roof and truss, precast wall panel, and the last one is precast column and beam. For cast in situ pad footing, which is cast in situ reinforced concrete pad footing, was proposed in this project. Pad footing are shallow foundation that take and spread point load to the soil safety. The pad foundation are preferred if the soil at the site have sufficient strength. Other than that, for cast in situ ground floor slab, the material construction used is reinforced concrete, which is cast in situ ground floor is a concrete process that is carried out in situ. Next is precast concrete hollow core slab. The precast concrete hollow core slab is a precast slab of a pre-stressed concrete. This is commonly used in multi-story residential building. It also known as the most environmentally friendly floor technology with a far lower CO2 footprint. For precast concrete staircase, constructed from reinforced concrete that has been precast and put on site. Precast stairs are superior option for speeding up construction on the job site that cast in place concrete. Next, prefabricated steel roof truss. The steel truss system serves to support the long span roof. Furthermore, this system is a high strength, lightweight of roof system that reduce on-site installation. This technology also has the ability to transfer the weight of exterior walls from building, as well as relieve the load on inner walls. Okay, for precast wall panel, precast system wall panel can have a variety of finishes, from highly ornamental exposed aggregate to foam face finish that is close to case in place, while saving time on site installation. The wall panel are lifted and sit in the desired position for the building once the concrete is firm enough. The last one of the framework of IBS system is precast column and beam. Precast column and beam offer a versatile alternative for a project structural component. Multi-story column, a case with cobble or alternative connection at intermediate level to suit the beam.
Hi, my name is Muhammad Zafar. So today I would like to present about the suitability for the IBS system. First is time consumption. In the use of the IBS system, the time factor must also be taken into this account. This is because each section will be installed on its own order. When there are a component such as column that has a problem, it will cause the order installation will be interrupted. The second is cost. The cost factor is also important. This is because the use of IBS can only reduce for the cost of the material only, but it will increase the other costs such as transportation costs, installation wages, and other. The third is the safe bearing capacity of soil. The bearing capacity of soil factor is also very important, especially when installing component for the foundation base. Poor soil condition will cause risk to the building. Fourth is the load to be supported. The main thing that may need to be taken into account in the use of IBS system is the load of the building. This is because it will determine the size and also the type of the concrete grade that will be used in the manufacture of precast concrete. If the calculation is wrong, it will cause the building a column cannot be supported the weight of the building and it may be collapsed.
Okay, the first is precast concrete hollow core slab. Manufacturer use high tensile strength, pressure strength, and single wire embedded in the element and create cast in one phase to the production without any formwork. Okay, the second is precast concrete staircase. Reinforcing concrete to strengthen and shape the concrete into a ladder that will be used in this project. Okay, the next is precast of wall panels. Variety of finishing from highly ornament exposed aggregate to a finish that is close to cast in a place. The fourth one is steel roof truss. High strength, lightweight roof solution that reduce on-site installation time. It also efficiently transfer to all weight to the outer walls of the building, reducing the stress and the internet walls also. Okay, the last for the fabricated process is precast column and beams. Develop and built to exact specification with optional feature and fittings. At intermediate level, multi-story columns are cast with a cobble alternated connection to suit the beams. Okay, for the next is connection detail. For the first connection detail is a pad footing. Create an excavated land to allow concrete pouring. After that, they're jointing each other with a bolt mechanically connected to the column spice. Okay, the second one is precast columns with the metal bearing plate in between the column dropped into each other. After that, the column is bolt mechanically connected to the column splice. Lowering the precast column into the place, then tightening the nuts. Third is a precast beams. Precast beams is a metal bearing pad used to connect the precast beam to the column cobbles. After that, the workers will welding plates are precast into the column and beams. Okay, the fourth one is a precast slab. Reinforcement bar will be installed initially, followed by formwork erected around the ground floor in accordance with the laying out criteria. And then the workers will use a mobile crane to lift the slab and set them on the framework. Slab are laid out according to the building design and plan that structure plan. Okay, for the next connection detail for this IBS case study is precast walls. To install the panels, the workers will use a metal plate and angles are also used to connect panels to each other, like this. Floor and roof elements. The wall panel then the workers will use the welder to bolt together. The next is precast staircase. Steel breaker are used to jointing staircase and then landing to the walls and beams, and ball. Then the workers are tied with balls are used to fasten in. Okay, the last one for the connection detail is prefabricated steel roof. On this point, they use a beam connection to secure with bolt and nuts. The purlins then bolt and nut to the truss. Underlayment material are covered with galvalume. Then metal roof panels are secured to the roof using screw. Okay, for the next is installation of procedure. In this installation, we have two type. For before the installation, and the second one is during the installation or during the project. Okay, before project start, firstly, client. We'll start the client. The client will ask the consultant to help him realize the idea from the client to build a building requested by client. In this situation, consultant maybe will suggestion the client to use IBS system to follow the idea from the CIDB request. Then the second one is a planning. After client agree with the consultant such as architect, engineer, mechanical and electrical engineer, surveyors and others will planning such as plan, contract, tendering and other thing. Then submission. After the planning or the documentation, the consultant will submit all the document to the local authority such as pihak berkuasa tempatan and Jabatan Kerja Raya and others that involved in government authority for the construction project. Then maybe some of few years or few months, the local authority will approve the project that without any problem on that plan or contractor and others. Then on that thing, consultant will hire a contractor to start the project. Then after contractor will be hired, at the same time they also can order IBS panels such as walls, slab, roof truss and others. The start the manufacturing, we've sent the real specification that used in this project. Then after the manufacture done, the manufacturer will send all that panels use a lorry to transport to the site. Okay. After that, right now we present to you about doing project. Okay, the first step is excavation. The contractor perform excavation work for the foundation before laying the foundation ground beams. This excavation work will follow the plan made by engineer and also be inspection by the engineer. And the second one is installation foundation ground beams. Okay, the contractor will lay the foundation ground beam according to the plan that has been set, and also after that, the contractor and also the client inspection will do inspection for the check ground beam is corrected followed by plan or not. Then the second one they use ground floors. They start with cast in situ ground floor slab. After that, the contractor can start activity the ground floor slab. We'll place reinforcement on the slab, then pour the cement on that slab. Okay. The fourth one is a precast columns. The contractor will use a mobile crane to transport the columns at each point that has been marked by the workers. When the column has been lifted by the mobile crane, the worker will attach the column with the bolts and nuts between the column and the plate. Okay. The next is the work for the precast walls. Okay, the precast was the contractor will use a mobile crane to lift the walls panels and then attach with the columns and also the slab with bolt and nuts. After that, starting with precast beams. The process use a mobile crane to lift up the beams. After that, the connection that used is a bolt and nut. After that, the process is hollow cast slab process. That means they use a mobile crane to lift up the hollow cast slab and then jointing together with a beams that has been installed. Then the contractor will use the same process until the all the story that has been set in the plan. Then at the same time, the contractor will use a mobile crane also to lift up the staircase precast IBS system to install the point that has been marked in the plan. The same method they use to connect the staircase with another panels that use a bolt and nuts. Then the last process they use is a fabricated steel roof truss. The structure part of the building is ready. Then they lift up the steel roof. Then they join together with the highest level story that with a connection detail. Also use some method that bolt and nut. Steel roof truss. The structure part of the building is ready. Then they lift up the steel roof. Then they join together with the highest level story that with a connection detail. Also use some method that bolt and nut.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zul Mukri Babu Hassan. I will explain a little bit about the IBS system for the schedule of modular system for this case study, which is Sekolah Kebangsaan Brickfields Kuala Lumpur. As we know, IBS system is wing with their many of component, which is fabrication, precast, in situ and modular system. So for this project, the IBS system that use is for the floor system. They use the hollow core slab, and the column beam system they use the precast concrete, and for the wall system they use the precast concrete also. So how the schedule of modular component function for this project? From I know, the modular component is function which is from the schedule modular component. How is it this system function is about how the all material structure of this component can combine installation and construct for the building until finished. For example, for the slab system, they made from manufacture precast hollow slab, and then for the beam and column they made from the manufacture with the standard IBS system MS 10664 from various part. And for the wall system is also same with the IBS standard. So all component and material will combine together to build the building until finish. Why in IBS system use modular component for the construction? Because as we know, IBS is wing with the time consuming, cost consuming and management performance. So by using the modular component, they can cut off the on-site working, which is to reduce the construction on-site work by perform the structure is made from the manufacturer. So let's continue to the other side. For example, In phase 1, for this building, the contractor and builders construct the pad foundation by using the in situ work or in situ platform. They have 28 pad foundation, which is the dimension of pad footing is about 1050 for the height, and for the length and width, and for the height is about the 400. So after the all pad foundation is ready to construct, they continue to the flooring system, which is slab. They install the hollow core slab for the flooring system. Usually for the IBS project, the slab usually in half precast and half concrete on site, which is in situ. Why? Because the half in situ concrete inside is for the tandam the all services, which is MEP system. IBS system usually use this method for the slab in flooring system. So after the flooring system have done, they continue to the beam, column, wall system, which is the all column, beam and wall will install with the schedule of modular component. So all column, beam and wall, they use the precast concrete from the manufacturer with the IBS standard MS 1064, and with the various of parts, which is for the part wall, they use the standard part of wall. For the beam and column, they use the part of IBS standard. After the beam and column and wall system is already done, they continue to the phase 3, which is after the 3 level already construct. So they continue with the roof system. The system method for this case study, SK Brickfields Kuala Lumpur, they use roof system by model IBS schedule modular component, which is before the roof system is installed at the building. The all component of the roof system will install by component to component to nampakkan dia sebagai satu roof yang lengkap before dia letak ke atas bangunan tu. So on this project, SK Brickfields Kuala Lumpur, they have a lot of IBS component schedule. So for example, the pad footing, they use the 1050 length and width, and the height is about the 400. And for the slab, they use the hollow core slab. So function of IBS component schedule ni is about to get it easier for the manufacturer to make the precast or fabrication of the component for the building. Second, for getting easier for the QS to the measure the all component that need for the project. For example, for the exterior wall, the manufacturer will cast the wall with the size that suitable with the window that used for the project. They have hollow wall cast in the middle of the wall to insert the window on site. The measurement of this dimension is already in the IBS standard and BQ requirement. So same with the staircase. The staircase use the precast concrete from the manufacturer. For example, manufacturer by following the requirement on the IBS standard, which is what type of the step that they need for this project, the project requirement, and after the staircase is already prepared for the manufacturer, then transfer to the site. Then the workers will install the railing on the site. It's just like a Lego system. It's just plug and play the all material or component inside. So summarize from the IBS schedule modular component is about the how the all material or component can be combined, installed and construct to be a complete structure. For example, they combine the wall, beam, floor to be a complete structure for the building. For me, in IBS system, for the modular component is include how the component can be coordinated from outside on site, how the transportation management from offsite to on site, and all these things can be contribute the cost efficient, time management, and reduce the work on site. Last but not least, for me, IBS system in schedule modular component is about the how the Lego toys boleh tercantum-cantum dan jadi sebuah structure atau bangunan yang lengkap. So for me, this is my pandangan how IBS system can produce the complete building. For example, for the exterior wall, the manufacturer will cast the wall with the size that suitable with the window that used for the project. They have hollow wall cast in the middle of the wall to insert the window on site. The measurement of this dimension is already in the IBS standard and BQ requirement. So same with the staircase. The staircase use the precast concrete from the manufacturer. For example, manufacturer by following the requirement on the IBS standard, which is what type of the step that they need for this project, the project requirement, and after the staircase is already prepared for the manufacturer, then transfer to the site. Then the workers will install the railing on the site. It's just like a Lego system. It's just plug and play the all material or component inside. So summarize from the IBS schedule modular component is about the how the all material or component can be combined, installed and construct to be a complete structure. For example, they combine the wall, beam, floor to be a complete structure for the building. For me, in IBS system, for the modular component is include how the component can be coordinated from outside on site, how the transportation management from offsite to on site, and all these things can be contribute the cost efficient, time management, and reduce the work on site. Last but not least, for me, IBS system in schedule modular component is about the how the Lego toys boleh tercantum-cantum dan jadi sebuah structure atau bangunan yang lengkap. So for me, this is my pandangan how IBS system can produce the complete building.
Okay, for IBS calculation score for the building, first, construction area. The total of construction area is 1171.3 meters square. Okay, for the IBS score part 1, structural element, the total area is 1171.3 meters square. For the coverage, 1.0. For the IBS vector is 50 point. Okay, for IBS score part 2, wall element, the total area is 1427.1 meter square. For the coverage is 1.0. For the IBS factor is 20 point. IBS score part 3 for other simplified, which is coverage 100%. For IBS factor, the total is 20 point. So the total of part 3 is 24.
For the conclusion, in conclusion, the demand for the use of IBS system is still not satisfactory because there are still many contractor and developer who still refuse to use this system because due to several factors such as lack of material resource, lack of cost, lack of resource. And order this situation can raise concern about the efficiency of the use IBS system. Therefore, the government must play an important role for implementing and developing the construction sector in Malaysia. Awareness. So that's all from me. Thank you.